Good morning, Thursday, May 7th. Welcome back, and let's get started. Today we are going to have you design another Google drawing that shows how ethanol burns. Now that you understand how to build the molecules and what they look like, now you get a chance to play around with them. First, let's give out a Yoshi to Jason Holmes. Jason Holmes, great job. Moved from a Wario all the way up to a Yoshi. Made some really great corrections on his Google drawing and showed that grit, the determination to get it right. So great job, Jason Holmes. We have about 13 Marios out there. The Marios are the ones that had everything drawn almost to 100% accuracy, or right there where you need to be. But we still have way too many Warios out there. Don't be a Wario. If you're a Wario, you're in jeopardy of not earning credit. And again, a 20 to 30-minute assignment is a whole lot better than 70 minutes a day next year. So again, get your stuff done. Just do your daily assignments. Not that hard. All right, so let's get into a question that I asked you yesterday. What is this? What is this? Well, it is what is called a blue heron rookery. And this is where blue herons will gather in the spring and early summer to lay their eggs and nests. And they generally do this in a group. So there are advantages to living in groups, obviously for protection purposes and rearing of young and things like that. You see these rookeries around once in a while. There used to be one behind Okemos High School. It is no longer really functioning, but if you are driving on Hagedorn Road, you may see the remnants in that wetland there. It's possible that they moved and started a new rookery here. This rookery is located, like I said, if you're going north on College Road towards Jolly, just as soon as you cross over 96. And if you look to the left, you will see this. I know that some of you are you may have parents, you may have to go to a doctor's appointment, or you may have to go somewhere towards East Lansing. You're probably going to see this rookery in this particular area right here. It's a pretty cool thing to see. You don't see them all the time, but this is where, if you look off to the distance, you'll see blue herons. It looks like there's one up in that corner there that might be sitting up high. Typically, they're in the water, but in this case, they can be in those locations. Kind of a cool biological phenomenon to witness. See if you can find it. Now, getting into when the ethanol actually burns, what kind of changes are occurring with these chemicals and how can we better understand that? That's what our goal today is to kind of wrap that up, so make sure we can understand it at the atomic molecular level. We know that there is oxygen, carbon dioxide, water, and ethanol involved in this thing. And we know that ethanol is primarily in the Petri dish, and that's what we are going to be seeing how that chemically changes. If you look into the bottom of the flame at the atomic molecular level, we see that we have, we can't forget that our air contains nitrogen, but we're also going to have this oxygen that's in there. And you can start to see that even some carbon dioxide, there's one there, not a lot, but you see lots of what are little ethanol molecules at the bottom of that flame. And you see that oxygen too. Nitrogen, but you're going to see that oxygen in that area as well, interacting with that. But you can see there's more nitrogen, but that does nothing. But again, this ethanol, this liquid, you can see that molecule there, and that's at the bottom of the flame. Well, what's at the top of the flame? Just think about that for a second. What would be at the top? Well, if you guessed yes, CO2, yeah, you're going to see more of that CO2 at that top, and you're going to see less ethanol in the flame because you know that it's going through some kind of chemical change. And so that's what we're going to look at, is how does that chemically change when we're doing that. Now, I'm going to demonstrate not using ethanol, but another molecule to show you how to go about handling your next Google Draw. So I'm going to switch over to the Google Drawing. And with the Google Drawing, I'm going to take and show you what you're going to look at here. So if we look at this, this is for methane, and what we have is a reactants side and a product side. And when we're dealing with these sort of things, what we're going to trace is sort of the atoms and how they're working here. On your Google drawing, you're going to be provided with most of the stuff. Instead of methane, you're going to have ethanol. All these molecules have been built for you. And there has been a slight color change. The oxygen is now blue, and it matches up with the other slides that I just showed you. So let's get into, what if I burn methane? What would I need? Well, on the reactant side, which of these things would be a reactant? And if you guessed, yeah, well, methane would be, you're right. So I'm going to take that methane molecule, I'm going to copy it, and I'm going to paste it. I'm going to copy one, and I'm going to bring it down here and put it in that reactant side. What would be reacting with that? Well, we know that anytime that we want to react with something, we're going to take it and we're going to then bring it in here with the oxygen. So with oxygen, we know that our fuels interact with the oxygen that it's in our air, and that's what produces our products. Now, what are our products? Well, we learned when we watched in an aquarium, we saw that water is a particular product that accumulated on the sides of the actual aquarium. And we also know that the flame gave off CO2, which caused the BTB to turn yellow. So we're going to put that CO2 down in here on our product side too. So we have our reactants here, and we have our products. Now, the rule is down here, atoms last forever. You can rearrange them into new molecules, but you can't add or subtract atoms. Okay, so let's tackle that first. So if we look at our atoms, when we look at our carbon atoms, I have 1 on this side, and then I have 4 hydrogen atoms that are here, and I have 2 oxygen atoms that are located here as well. So now that I have those listed, I have to have equal amounts on this side. We call this a conservation of matter. Matter cannot be created nor destroyed. So we can't have more atoms over here or less. These atoms are getting rearranged when it chemically changes. So let's see what we have over here. Well, we have 1 carbon atom here. We have 2 hydrogen atoms, and we have 3 oxygen atoms. Well, that isn't really what we truly want in this situation here, because these are not equal. So we have to come up with a way to balance this out. So what you're going to have to do with your ethanol drawing is figure out what is the correct combination. Well, since I have more oxygens over here, and what I'm going to do is I'm going to take another oxygen, and I'm copy that, and I'm going to paste it, and let's see what I have here. Now that bumps that up to 4 oxygens here. Okay, so we have 4 here, and again we have the 3 here. Well, what if I take and I copy this water and I place that? Oops, I'm gonna undo that there. But what if I take this water molecule, copy that, and I place it in here now? Now let's see if I did. So I added an oxygen over here, and over here I added a water to see if I could get this to balance out a little bit better. Carbons have not changed, they're the same. Hydrogens, well, I got 1, 2, 3, 4 hydrogen atoms on this side. So I'm good there, and I have 1, 2, 3, 4 oxygen atoms on this side as well. And so now I have equal amounts of atoms, and we are all set for that. The final thing I would have to do with this particular drawing to submit it I'd have to be able to put the energy in according to that. Would light energy go on this side? Would heat energy go over here? Would chemical energy go over here? That's what you have to decide, where these cards would go. Energy lasts forever. You can't create energy or subtract it. So you basically just have to put these cards in the right places according to where they should be according to this reaction. So you just simply pick those cards up and put them in the right spots and get your molecules built, and you will be all set for your final Google drawing on how ethanol burns. If you have any questions, feel free to email or send me a message. Otherwise, good luck and have a great day. Thanks.